A flow path is the direction of movement of heat, smoke, and air from areas of high pressure to areas of low pressure inside and outside of a building. As combustion occurs, heat is released, causing higher pressure near the fire. Heated gases move upward and outward because of the pressure differential. As the heated gases move upward and outward, cooler, oxygen-rich air is drawn into the base of the fire. This is the beginning of a flow path. Once heated gases expand near the ceiling, the area of high pressure increases and moves downward until it is able to exit a door or a window opening. A neutral plane is established when cool air enters the lower part of the window and hot gases exit the upper part of the window. This configuration is called a bidirectional flow path and typically occurs in a closed compartment with only one opening. When multiple openings exist, unidirectional flow paths can occur. Several variables help establish this flow path, including exterior wind, size, proximity, elevation, and location of openings. The simplest form of unidirectional flow path occurs when conducting vertical ventilation. The open front door becomes the inlet and the roof vent becomes the outlet. Another form of unidirectional flow path is in a multi-story dwelling. Suppose an upper floor window breaks. A unidirectional flow path will occur when air enters the first floor door opening and exits the upper floor window. In almost all cases, unidirectional flow paths will establish with a low entry and high exit, or low to high. A special wind-driven unidirectional flow path can occur on one floor of a structure when a window on the windward side breaks and the wind increases pressure in the structure, forcing air through a leeward opening. Use of positive pressure ventilation can also create wind-driven flow paths. As flow paths are established, fire will grow and travel in the direction of the flow path. Let's take a closer look at flow path in a controlled experiment. This prop was designed by Adam St. John, a fire research engineer with ATF Fire Research Laboratory. Our prop is comprised of two chambers, or rooms, stacked on top of one another. They are connected by a third chamber, which simulates a stairwell. Movable openings, or doors, are found on either side of both chambers, connecting either to the outside or to the stairwell. The stairwell has two outlets to the outside, one of them simulating roof ventilation. As we begin, all openings are closed except the door on the left of the lower floor. When we ignite the fire, air comes in low and exits high, moving in cool and going out hot, in a bidirectional flow through one opening. Even when the door to the stairwell is open, the flow remains bidirectional. However, once the upper door of the stairwell is opened, the change is almost immediate, moving from a lower inlet to a higher outlet. This flow path is unidirectional and is caused by heated air rising. If you were to attack this fire against the flow path, it would be much more difficult to get water to the seat of the fire. However, if you were to work with the flow path, putting water in from the lower inlet that is taking in cooler air, the mist and water would flow along the flow path toward the seat of the fire. If the upper door were closed and the roof vent were opened, the unidirectional flow would be even more pronounced. This illustrates how improper roof ventilation can make a fire worse instead of improving the situation. If the upper door and the roof vent were closed and the door into the upper room were opened, the flow path would continue to be unidirectional, this time wrapping itself back through the upper room, igniting it and its contents. This illustrates that flow paths are not linear. They can travel in unexpected directions, but always according to the laws of physics. They will almost always flow from low to high. As a firefighter, understanding the elements of fire behavior, such as flow path, is essential to your safety.